Hi, my name is Xin Zhang. Our discussion will start with a brief recap of our intended contributions. Namely, we develop formulas for Weiss-Weinstein bound in the problem of estimating GNSS Doppler frequency. And based on the formulas, a new test point selection method is proposed. An initial comparison between the two most discussed modern Bayesian bounds in GNSS community, that is WWB and ZZB of Zakaï, is performed, and some interesting findings are reported. We then move on to a detailed overview of previous arts, which corresponds to section 1. And this part is intended to serve as a condensed tutorial on performance lower bounds for static parameter estimation problems, not only in GNSS, but in a more generic sense. Tightness is the central topic of every performance bound, and the tightness, or put it in other words, that is the gap between the predicted and the true estimation error curves, can always be narrowed. And in this paper, we commit ourselves to narrowing this gap by assigning the bound error curves across 4 different signal-to-noise ratio, that is SNR regions. We reinvestigate the opportunities in tightening the bound. Next, we present our solutions. But before that, we're stipulating that we are estimating the normalized digital frequency in a GNSS receiver, and we are trying to bound its estimation error in medium to low SNR regions with a focus on very weak signals. We believe that choosing the right hyperparameters of a correct bound family is the ultimate key to the problem. And therefore, we propose a method to choose the exact number and locations of the test points. Besides, prior probabilistic assumption for the uniqueness of the parameter should also be accounted for. We are estimating circular frequency, so its circular nature should be taken care of, say, by Mises, an analog of Gaussian distribution in circular statistics. Finally, Monte Carlo simulations were conducted to justify our speculations and proposals. The most intriguing finding in the community of navigation, Zakaï bound is the most discussed bound, in addition to the well-known Cramer bound. However, Weiss-Weinstein bound outperforms ZZB in the current settings, but this performance gain is inverted in the neighboring SNR regions. This alternating behavior might be an indicator telling us to choose the right one for different problems. We will close with some thoughts on where performance lower bounds for modern GNSS receivers is headed from here. We use MATLAB to do all the analysis, and the code is fully open sourced at the GitHub repo. Thank you.